So again, with this one, we are looking at finding the first derivative. Recognize the fact that when you have the square root, you can rewrite that to an exponential 1/2 power. And as I'm looking at this, I've got two different things going on inside here. On the left-hand side, I have the chain rule that I have to do on the outside first. And inside, you'll see that you're going to also have the chain and the product rule in that order. Over on the right hand side, you'll see you have xy, and for this one you will also need the product rule. So let's go ahead and get started with this. So in order to take d dx of this first piece, the first you do is take the derivative of the outside, and when you take the derivative of the outside, nothing changes on the inside. It's just xy, and that becomes 1/2 minus 1, which leaves me to the negative 1/2 power. Now, the derivative on the inside, all of this, that is where I need the product rule. So you can do this two different ways. Again, if you want to use the UV notation, you can say u is equal to x. The derivative of x is just 1. For v is y. But again, remember what we're doing, we're finding, when we find the first derivative, you're taking the derivative of y with respect to x. So what you get is dy dx. Now the derivative of y itself is just 1. So I multiply all of this times 1 times y, or just y, plus x times dy dx. And just remember, all of this is the product rule, and it's only for this first portion, for the left-hand side of the equation. Let me go ahead and remove this. And we are now going to focus on the next side, the product rule for x squared y. So using the same UV notation, if I let u equal to x squared, the derivative is 2x. For v equal to y, the derivative of v with respect to x, I need to have the dy dx there, and then I multiply that times the derivative of y itself. The derivative of y itself is 1. So all of this is going to equal the derivative of the first term times the second, which in this case is going to be 2xy, plus the first term times the derivative of the second, which in this case is going to be x squared dy dx. And the last piece, just making sure you recall that the derivative of 1, that would just be plus 0, so you don't really need to have that in there. All right, now what are we going to do with all of this? We have to simplify it. I'm going to simplify this first by taking this first term and rewriting it as 1 over 2 xy. I'm going to write this as to the 1/2 power, but you could also write that as a square root if you wanted to. I'm taking this and I'm going to multiply it times y, which will give me a y in the numerator. Then I'm going to do the same thing and multiply it times x dy dx. When I do that, I'm going to have it be plus 1x all over 2 xy to the 1/2 power dy dx. And this is all equal to 2xy plus x squared dy dx. Now the next thing in the next step to solving for the derivative is I need to isolate dy dx. Again, that's the goal. So what are the two terms that have that in that? The two terms that I have here and here. So the first thing I need to do is put those on the same side of the equation. So I'm going to take and bring this first term and write it over here. That leaves me with x over 2xy to the 1/2 power dy dx. Now, the next thing I'm going to do is I'm going to take this term that I have here, move it across the equal side. I do that by subtracting it by both sides, and that's going to leave me with minus x squared dy dx. Now, the next term I need to fix out is this first term on the left-hand side needs to move over. I do that by subtracting it from both sides. So that's going to be negative y over 2xy to the 1/2 power. And finally, I'm going to take the 2xy and just bring that down so that becomes 2 plus 2xy. Over here on the left-hand side, I'm going to factor out the dy dx, leaving me with x over 2xy to the 1/2 power minus x squared is equal to negative y over 2xy to the 1/2 power plus 2xy. Now there's a little bit of a choice of how to do this here. You could find a common denominator before dividing, but just try to get all of this on the same slide. So what I want to do for both of these now is divide both sides by that x over 2xy to the 1/2 minus x squared. And all of this becomes 1. So in order to simplify and find out what dy over dx is equal to, I want to take this complex fraction that I have, and if you look, the denominator for both of them is 2xy to the 1/2. So I want to multiply all of the numerator times 2xy to the 1/2 and all of the denominator by 2xy to the 1/2. When I go through and multiply 2xy to the 1/2 here, the numerators and the denominators cancel out, and I'm just left with negative y. Now, I do want to do this one out with you. This becomes 2xy times another 2xy to the 1/2 power. And with this, what you can see here is this xy and this xy are both the same. I can add those together and combine the 2's, and that will leave me with 4x, the quantity of xy to the 3/2 power. And again, what I did there is that's 2 times 2, which is my 4. This is xy. Think about that as being to the quantity of 2 to the first. And over here, this is xy to the 1/2, so I can add those exponents together. 1 plus 1/2 is 3/2. Now, looking at the denominator, how do I go through and simplify that? Again, 2xy to the 1/2 times 2 in the denominator times 2xy to the 1/2 in the numerator. That cancels, just leaving you with an x. and this is just minus now 2x squared xy. Both of those are to the 1/2 power. And I can finish that up by combining those x terms. So I have 4xy to the 3/2 minus y all over 2x to the 3/2 y to the 1/2, and that is negative plus x. And what I did with that, again, this x just went ahead and came down, and then this is x squared, this is x to the 1/2, 2 plus 1/2 is 3/2, and that's y. And this is definitely one of the longer questions in this section.